Three more properties today. Actually four, we'll get there. But the first three I'm going to look at is product property, quotient property, and the power property. And I just want to go over each one quick before we do some examples. When you're looking at the product property, what you should notice is that, of course, there's a product there, multiplication. But what follows with the multiplication is the addition of logs. So whenever you see a problem that has an adding of logs, this property should be the first one that you kind of look at to go to. And how this works is if you're adding logs together, like log 3, 9 plus log 3 of 3, right? First I'll have to have the same base. You can't use these properties if the bases don't match, and of course they will, okay? Then, what this m and n mean would be this, the 9 and 3. So to make these two logs, the only way to add these two logs together would be to multiply what they're log of. So this would become log base 3 of 27, because 9 times 3 is 27. And then you can even go one more step and solve this log. Remember how to solve a log? Just had a quiz over it. Convert it to exponential form. 3 to what power is 27? So what does this log equal? This log would equal 3. Okay, so that's using the addition property, right? Addition product property of logs. Subtraction is pretty much the same thing. When you're subtracting logs, let's do log of base 5. Okay. When I'm subtracting logs, I'm going to change that into division. And the key with this one is the first one has to go over the second one. You can't switch the order in division. So when I write this as a single log, I'd have log of base 5 and then 50 over 2. What is 50 divided by 2? 25. I can now solve this log. 5 to what power is 25? There's my answer. Okay. The third one is the power property. And this property goes both ways quite a bit. If you have a number in front of a log, that can be written as a power. If you have a power, that can go in front of a log. What does that mean? If I had log 327 to the 9th power, I don't want to do 27 to the 9th power and then solve 3 to what power is that, because that's going to be a really big number. So to simplify it, I can use my power property, take this 9, put it in front, and now it becomes 9 times this log, which I can now isolate this log, solve it. 3 to what power is 27? 3. So I'm really doing 9 times 3, which is 27. Okay. All right, so now let's look at some of our notes here and go over those together. First example, what you should notice is that I'm subtracting. When I'm subtracting logs, how do I make it into one log? Divide. So this is my m and n. This is what I'm going to divide. So log base 2, I'm going to have 9 over 3. What is 9 divided by 3? 3. And that's as far as we're going. We're just making it into a single log. So if I look at the next one, I should notice that I'm adding logs, but before I can add the logs together, I can't have any numbers in front of the log. So this one's okay, but see how I have a 5 in front of that log? I can't have that. I have to move it first. So if I have a number in front of a log, I can use that power property, and I can move it back as a power. So it becomes log 3 to the 5th power plus log 4. And then I can start simplifying. What is 3 to the 5th power?
Shoot. 243.
Good. And then when now I'm adding two logs. There's no numbers in front anymore, so now what do I do with those numbers? If I'm adding, what do I do? Multiply. So what's 243 times 4? Okay, so then I'm done. Oh, 972? Let's jump down here. Again, I'm going to subtract these logs. Can I use my subtraction property yet? No. What do I got to do first? Very good. I have to move this 4 back as an exponent. I can't have anything in front of that log. Then with subtraction, what operation am I going to do? Divide. So I'm going to take this m to the 4th over n. It has to be that order. And I'm done. I can't simplify that anymore. What about the next one, 14? I'm subtracting, but what do I have to do first? I have to move that k back as a power. And then I'm subtracting, so that means divide, so log, and I have 5 over 2 to the k. Have more than one, you're going to use your properties and you're just going to work left to right. So I'm going to put these two logs together and make that a single log, and then I take that log with the third one, combine those with the fourth, and so on. Okay, you just work left to right. So let's look at the first two. I'm adding these logs together. So what do I do with the x and y? Multiply. So it's x times y, like this. And then I still have this log, so I have to subtract. Now I'm subtracting these logs. So what do I do with this? Divide. So I get it down to a single log, xy over z. Let's try one more. So go ahead, combine those, you're adding. If you can go ahead and start doing that in your head, right? Log base 3 of 4 times y times 8x. Some of you might be able to skip that now. If not, do the first two. So you'd get 4y. And then you would combine those two. If you're multiplying, you can multiply the 4 times 8. You can do that. So you get 32 and then xy. Usually your variables go in alphabetical order. At this first one, you're looking for what multiplication or division is there? What operation's going on? You should know, yeah, it's multiplication. I'm taking 49 times x times y times z. Okay? How do I undo the multiplication? I'm going to make it into adding logs. How do I expand log multiplication? I expand it by adding. So this is going to be log 749 plus log 7x, log 7y, log 7z. One of those logs I can simplify. Which one is it? You should notice that this first one here, 7 to what power is 49? 2. So this equals 2. So it does go one more step. Whenever there's a log that you can simplify, you'd want to do that. Second one, what operation do you see going on there? Division. How do I undo division? With subtraction. Very good. So this becomes log BB minus log B of x because it was B over x. One of those I can simplify. Which one? This one, because B to what power is B? 1. What about 21? What can I do there? What do you notice? The squared, what can I do with that? I can put it in front.
Oh, yeah.
Okay? So I would do 2 log A. Now, some of you might notice, right, and I think this is what you notice, is that A squared is A times A. So I could start by expanding this by log A plus log A, because A times A is A squared, right? But what is 1 log A plus 1 log A? 2 log A. Okay? So even though you started different, you still end up the same. And that happens a lot in mathematics when you're given a lot of rules, a lot of properties, and then you're just told to simplify. You might take a different route. About this next one, what would you do first? There's 2 things going around here. I have multiplying and a power. So we're going to undo the power first. Okay, so move that 2 in front. Right, but I'm not done yet because I still have a multiplication right here. And I undo multiplication with addition. Right? So this 2 goes to both. So 2 log 3, 2 plus 2 log 3x. Now I'm done. There's nothing else to break apart to simplify. What about this next one? What would I have to undo first? And some of you might say the exponent, but what I want you to recognize is this squared is not going to the 7. The squared is only going to the parentheses. So I would first have to break apart this 7 times this with addition. Then I can take that squared and put it in front of the log. So you have to be careful when you're using that power property, that exponent property, that it's only going in with the log that it's the power to. So one more step. I would have 2 log 3, 2x minus 3. And then I can't break apart this 2x minus 3. That just stays. 25. I see that I have some powers, I have multiplication, I have division. What would I need to break apart first? The division. You need to break apart the division first. Yep. Think order of operations, right? You gotta unbreak that division. So I'd have log a squared b cubed minus log c to the 4th. Okay, break apart the division. Then I can break apart this multiplication. Log a squared plus log b cubed minus log c to the 4th. And then one more step. I can use the power property and move all those powers in front of the logs. So 2 log a plus 3 log b minus 4 log c. I didn't put this in to trick you. I just want you to remember, how do you fix a negative exponent? Remember? What do I do with the negative exponent to make it positive? You have to switch the level. So if it's negative 2 on top, I have to then put it on the bottom to become positive. And then I can break this up just like I did before. Okay. Try to visualize in your head so you don't have to write so much out. You know that this is going to break apart by addition, and this 4 is going to go in front of the log. So log 10 plus 4 log m minus this 2 is going to go in front of the log. Okay? So if you start visualizing and thinking ahead what it's going to be, you're going to save yourself some writing room, some work. Okay? If you have to write down all the steps, that's fine. This example is just like the one before. But you can do that. You can skip steps. That's okay.
Would it have been fine if we did the negative one first, or like we did the division first?
Yeah. This one, how would I undo division? Subtraction. I can simplify one of those. Which one? 5 to what power is 25? 2. Okay. I did throw in a more challenging one if you look at this last example. I know some of you need a challenge. Okay. I am taking log base 8 of 8 times this square root. So I need to break apart the multiplication first. So log 8 plus log 8 square root 3a to the 5th. I can simplify log 8 because 8 to what power is 8? 1. Now, you do not want to have square roots in your logarithms. So what can I do with this square root? So I can rewrite this log with a power property and say 3a to the 5th to the 1/2 power. Because then I can take that 1/2 and put it in front of the log. So I'd have 1 plus half log 8 of 3a to the 5th. Am I done? No, because now that just opened up a new expansion. What can I expand? 3 times a to the 5th can get separated by addition. And that 5 is going to go in front of the log. Okay? So I have 1 plus, and then this half would go to both parts, remember. So half log 8 of 3, half log a to the 5th. And then the last step would be taking this 5 and putting it in front of the log.
So it'd be 2.5.
5 halves, yep. And that's expanded all the way. Your calculator, let's start with something that we know, okay? Let's start with something like log base 5 of 25. We know 5 to the 2nd power is 25, so we know this log equals 2, okay? But how do I do that in my calculator? Your calculator, if you remember, only does log of base 10. Don't forget that. That's very important. Your calculator only does log of base 10. So I can change this log to log of base 10. I do log 25 over log 5. Okay, so you can use the LOG log on your calculator. Do 25, close the parentheses, divided by log 5, and then you should get 2. Make sure you don't mess up the order. I tell kids the base of the log always goes in the basement of the fraction. So you don't mess up the order. Okay, that base has to go on the bottom. So let's try some. This formula is good for problems like this. 2 to what power is 9? Well, that's going to be some crazy number. Okay, so instead of having to graph it and find the intersection, now we can just pull out our calculators and do log 9 divided by log 2. And what do you get? Approximately 3.17. Good. Let's use approximate sign since we're rounding. This one is going to be log 20 divided by log 12. Again, the base of the log always goes in the basement of the fraction. What's that? 1.21? Round to the hundredths. Okay. Try the next two. So if I do log 7 divided by log 4, what's that approximately? 1.4. And then log 54 divided by log 3 is what approximately? 3.63. 3. So when I'm subtracting logs, what am I going to do? Divide. So log base 2 of 4 over 16. What is 4/16 reduced down to? 1 over 4. Now, if you don't know 2 to the negative 2 equals 1/4, right? If you don't know that mental math, this is where that change of base formula will help you. You can do log 1/4 divided by log 2 on your calculator, and it should tell you negative 2. Okay.
Wait, how did you do that in your
What? Yeah.
So subtraction, I divide log base 2, 96 divided by 3. What is 96 divided by 3? 32. 2 to what power is 32? If we don't know, we can do log 32 divided by log 2, and what's that? 5. Don't forget, when I'm subtracting, to use that property, this 2 does have to go there first. So log 327 minus log 3, and what is 3 squared? 9. Let's go ahead and just do that. Then subtraction means divide log 3 of 27 over 9, which is 3. And 3 to what power is 3? 1. So again, adding, I'm going to multiply. So 12 times 3 is 36. 6 to what power is 36? 2. Okay. Don't forget, right, you have to move it back as a power. So log base 4 of 48 minus log base 4 of, what is 9 to the 1/2 power? 3. Then I can divide. So log 4 of 48 over 3. What's 48 divided by 3? 16. 4 to what power is 16? 2. So again, if you have numbers in front of the log, you need to move those back as a power. And I want to, 15 to the 1/2 power is the same thing as what? Square root of 15. And you'd want square root because what you should notice is that this is a square root. And we learned the last chapter that if they're both square roots, what can I do? I combine it into one square root. Remember that property?
Yeah.
Right? As long as they're the same index, you can do that. 15 over 75 reduces to what? 1/5. Right? Now, you kind of have to foresee that 5 to the negative 1 is 1/5. But I can't do that until I move this square root. How can I move that square root? I can change it back to a 1/2 power. So log 5 of 1/5 to the 1/2 power, I can then move it in front and have 1/2 log 5 of 1/5. Then I can say, yep, this log 5 to the 1/5 equals negative 1, because 5 to the negative 1 is 1/5. So really I'm taking 1/2 times a negative 1, which gives me a negative 1/2 as an answer.